this one trick will make you a fantastic programmer. What is it? You have to understand there is no perfect programming language, so you have to learn different ones to improve. This will make you go to the next level. Study all those languages and you will improve. In Python you learn objects, you have a system where you can do dynamic changes that are not possible in Java or C#. Very good, objects, all this aspect. In Haskell you learn functional programming with functions, with a static type system, with algebraic types, all these cool things, pattern matching, you focus here. And Haskell made popular the list comprehensions that you use in Python and other languages. Rust has this low-level aspect to it in comparison to the other languages. It has a type system that can reason about resources, very good for parallel scaling, and that's really cool. And even you can do a little bit of Prolog. You learn to, and you have this second order of thinking about languages. Use languages that are maybe new and work like Julia. You can use it for things where you use Python for algorithms or for statistics, for visualizations, for statistical models, Bayesian computing. You can use Julia and you get to learn to think about multiple dispatch. Very cool. Just study multiple dispatch. What is it? What is Julia? And try out the language and see that it's faster than Python, that it has very good package system and a good community of really advanced programmers where you can learn. And why do we have objects? Why do we have a dynamic kind of runtime changes to your code, or you can change your objects or classes even at runtime? Where does it come from? In 1962 we had John McCarthy, very cool. He made this paper on Lisp. Very cool idea to think about how to bootstrap a language, how to clearly define it nicely, and also where the object comes from. Objects were kind of invented around 1961, but they were like a kind of the modern way to think of objects, like in Python also, very much comes from Smalltalk, a language done in 1972, extended until Smalltalk 80. And it's very cool if you have like the modern Smalltalk, like Far or instance, you do a tutorial there. It's a very different way to think about programming. Very cool. And if you like static types, you can expand your horizon to even use dependent types, another community. You can experiment with experimental languages like Mojo, doing a combination of Python and Rust, and also cool ideas there. And last but not least, there is even a very advanced Prolog that you cannot use for real-world stuff, but it's even cool to see how a modern Prolog could work in the research world. It's called LP Lambda Prolog. Very cool. So this is how you study and get to intermediate and advanced thinking. You study all these languages. Then, if you study the languages, you try to have programming exercises for intermediate advanced thinking. And one exercise by Dijkstra is really strange at first. Program with the statements where the order doesn't matter. Each line in your program can be executed in random order and it still will work. It kind of maybe blows your mind. How should that work? But the idea is we often use this imperative thinking. And even in an imperative language, we can program declarative. So how do we do it? Each statement has kind of a guard where it states the requirement for this statement. So you add these requirements for each statement. So in case we have this case, then we do that kind of thinking. And of course, if you every line can be executed in random order, this is a more robust way of thinking about programs, because you have to be declarative. There is no implicit order, and that kind of reminds you how you do stuff. A very cool exercise. Just try it out and you will learn and improve. And last but not least, a very cool exercise you can do. That's kind of, many people do this, but you know, Alan Kay, for instance, got the Turing Award for object-oriented programming, or Conor McBride, working in the dependently typed community, actor community. Extremely cool what they do. They bootstrap from zero. So you write a program or you solve a problem, but you want to have the minimum things that you use or have. So for instance, you could use a language, but a programming language, but you avoid to use the standard library, you avoid to use if or while. So normally you want to use, of course, that, but in this exercise you don't use it. You write your own if statement, your own functions, your own loops, whatever. You can use a trampoline or just executing a function certain times until some condition is met. You can do your own stuff, your own for, and try to have this. Start from zero and bootstrap everything. Very cool. You are a lot more flexible afterwards. If you have your own if, you can change it later on. And in many languages you cannot change the if later on, so you get flexibility. And you start from almost nothing. Maybe you want to assume some numbers, or you don't want to implement your own plus or whatever. If it doesn't make sense, you use the standard library. But you try to keep it very minimal and bootstrap everything else. So really cool. You can do that, and you even can also program first your own programming language, or general one, like implement your own Lisp and then solve your problem. Also very powerful. You learn how to bootstrap really from zero, and you learn how you can even adapt your own programming language, maybe for your purpose or your liking. Or you use a domain-specific languages. Wikipedia, you know, it's kind of HTML or SQL for a specific domain. And you can do that, implement your own, but not for SQL, but for your specific problem. Very cool way how you do it. One way to implement DSL is you take a PEG, a parsing expression grammar. It's a very good parser, and you parse your DSL language, and you compile it to a general purpose one. That's one way to implement DSLs, which is very nice. You can also go down the actor dependently typed route. You can bootstrap from zero there. Conor McBride has this, you see the link below, this way of bootstrapping everything. Then you define numbers, then you kind of bootstrap everything, and he goes on and on until you have kind of windows in a GUI. Very cool. The other aspect is, last but not least, very cool. Study this. I command it to you. Very cool tutorial on Lisp, how you implement it yourself. You learn a lot by doing that, because it's very concise, elegant, short to the point, kind of what the idea of Lisp was, and you can implement it. Very cool way of bootstrapping your whole own programming language, and you learn a lot by doing that, because you can expand it. Whatever you want, you can put in your language, and it's very handy if you know how to bootstrap your own tools, make your own programming languages, have your own DSLs, you learn all to do that. So, very cool ideas and exercises for you to improve